this second lecture of toppling, I'm going to discuss various conditions under which body may undergo toppling or sliding. So for this purpose, I'm considering this first case in which a block of mass m and height h is placed on a rough horizontal surface. This is block, mass is m, and this length I'm taking, breadth I'm taking it as b, okay, and height of this block I'm taking it as h. Now, if I apply a force F at an arbitrary position, at an arbitrary height from the ground, I'm applying a force F. So when you apply force F, obviously the frictional force between the block and the surface will be in this direction. First thing that I would like to discuss here is, what if the applied force is less than the limiting frictional value, that is mu s into small m into. This is the first observation. That is, when the applied force is less than the limiting frictional force value, then what happens? This body cannot undergo translatory motion. That means no sliding. Body cannot undergo sliding. But what about the toppling? Because here the toppling is decided not only by the applied force, it is decided by the height at which the force is being applied and the base of the block. Because of which I'm going to go for the toppling condition. So for this toppling condition, again, I'm considering the talk about the center of mass. This is the center of mass. So when the body is about to topple, then what happens? Gravitational force mg will be always vertically downwards only. And when the body is about to topple about this edge, then the normal reaction will shift to one of its ends like this. This is the line of action of normal reaction. Okay, so when the body is not sliding, that is, the body is not moving along the horizontal direction, what can you write down? Along the forces along the horizontal direction, the applied force should be equal to the frictional force small f, which is not mu s into mg. Mu s into mg is the limiting frictional force value. Here the body is not moving. That means the applied force did not reach the limiting value. Okay, condition for rotation. So in this case, when the body is about to rotate, okay, in that condition, the configuration may look like this. This is the horizontal surface. Am I right? Now, in this case, I am writing the torque equation about this tipping edge. Let me call this edge is A. About the edge, I am writing down the equation for. Okay, the height at which the force is applied with respect to this base, I am taking it as height is h only. Okay, so with respect to this point, now the frictional force will act in this direction. This is the direction of frictional force. This is the direction of normal reaction, and this is the direction of gravitational force, mg, vertically downward direction. Out of these three forces, which are producing torque in clockwise sense, torque in counterclockwise sense, about this point A. About this point A, due to the applied force, the body has a tendency to rotate in clockwise sense, and due to friction force also it is in clockwise sense only, and counterclockwise sense torque is up. So here the torque due to friction force is 0. I'm sorry, because why? Because the line of action of friction force is passing through the point of contact. Because of which torque due to this friction force is 0, torque due to normal reaction also 0. The only forces which are producing torque over here is the applied force and the gravitational force. Applied force is producing clockwise torque with respect to point A, and the gravitational force is producing counterclockwise torque with respect to A. So because of which, I can write it as therefore clockwise torque is equal. What you can write? Force, applied force mg, the applied force F into the perpendicular distance between the line of action and the point of contact is how much? I am taking arbitrary point as h. And anti-clockwise torque, I am writing torque equation in counterclockwise sense. Counterclockwise sense, who is producing the torque? Mg, the force mg into perpendicular distance between the line of action of gravitational force and point of contact. This is nothing but breadth I have taken as b, no? So half of the B is how much? B by 2. So when the body is about to topple, these two forces, these two torques should be equal to each other, because of which F into H, this H I'm writing as H maximum height at which I can apply the force, is equal to what you can write? Mg into B divided mg into B by 2, through which I can write down the expression for H max is equal to what you can write? Mg into B divided by 2 times the applied force. So through this, what I'm going to conclude here, when the applied force is less than limiting frictional force value, body cannot undergo translatory motion. But if you keep on shifting the point at which you are applying the force up to a maximum height h, what happens is body cannot topple. If the applied force, the height at which the force is applied is greater than h max, that means you should have at this point, if you apply somewhere over here which is greater than h max, then what happens? The body will start to, because this torque due to the applied force will be more than the torque due to gravitational force, because of which body will topple about point A. Body will rotate about point A. So because of which I can write down this as the condition for toppling. That means here what we can conclude. So in the nutshell, I can write down this like this. So if the applied force is less than limiting friction value and the height at which the force is applied is less than h max, then what happens? Body neither topples nor slides. It can neither slide nor topple. This is observation number 1. Second thing that I would like to talk about is, what if the applied force magnitude is equal to limiting friction value, that is mu s into small m into g. When the applied force magnitude is equal to limiting friction value, then what happens? Body is about to slide. The body is about to slide. In that condition, what you can write down? Along the horizontal direction, applied force is equal to frictional force, which is nothing but mu s into small m into g. So if you substitute this back in this expression for h max, therefore h max is equal to what you're going to get here? mgb divided by 2 into what is f? F is nothing but mu s into small m into g. mg gets cancelled. Therefore h max is equal to what you're going to get here? B divided by 2 times mu s. This is very, very important observation over here. What's happening? When the applied force is equal to limiting frictional force value, the body is about to slide, and if the height at which you apply the force is less than h max, body, what happens? It will not topple. If h is equal to h max, which is nothing but b divided by 2 times the mu s, then what happens? Body is about to topple. So in some books he may say impinging, toppling motion is impinging, something like that he may say. But I'm telling it as body is about to topple. That means if F is equal to limiting friction mu s mg and H is equal to H max, the body is about to both translate as well as both topple. And second thing is, the thing that you should remember here is, this H max is depending on breadth of the object and the coefficient of friction. It is nowhere depending on the height, on the weight of the object, or the magnitude of force. That means when H max is equal to B by 2 mu s, it doesn't matter what force you are applying on the body, and it doesn't matter what is the weight of the object. For any weight of the object, body will start to topple. This is very, very important point. That is, toppling is independent of the height of the object, or the weight of the object, or the force of the object. The point on which it depends is the height at which you are applying the force with respect to the surface on which the body is resting. If this height is greater than B by 2 mu s, then what happens? For any value of weight and height of the object, body will topple. This is very, very important observation that we should keep in mind. And second one, and the third one, and the last one that I would like to talk about is, what if the applied force magnitude is greater than what you call it as mu s into small m into g? What if the applied force magnitude is greater than mu s into small m into g? In some books, it is written as the force is for F divided by mg value is somewhat greater than mu into s. Then what happens? So when the applied force magnitude is greater than the limiting value, what happens? Body starts to slide. Body starts to slide. And H max, the height at which you are applying the force, is greater than H max. If the point at which you are applying the force is greater than the H max, what happens? Body will topple. So the condition for both translation and toppling, sliding and toppling, is the applied force should be greater than limiting frictional value, and the height at which you are applying the force should be greater than the H max given by B divided by 2 mu s. So all through this, how many conditions we derived? One is no sliding but toppling. Here sliding as well as toppling. Here about impinging motion. Here both sliding and toppling is taking place. So for sliding, you should consider the condition for limiting friction. For toppling, you should consider the condition for what you call it as height at which you are applying the force.